Let's say you're building a model to decide whether or not to make a loan. You don't want to discriminate based on gender, so you decide you will not use the gender of the applicant as an input feature. How about the occupation? Surely that's relevant. If someone's a street vendor or a CEO, that's going to affect their ability to pay back the loan. How about if someone is a hairdresser or a high school sports coach? In the real world, occupations are highly gendered. Because machine learning models are trained on real-world data, you may have removed gender from your loan application process. But the use of occupation as an input will mean that gender leaks through. Why does that happen? Machine learning models learn to understand word meanings by looking at how words are used in books and magazine articles. Based on how words are used in books and magazine articles, the machine learning model has learned that maid, for example, is a female word, as is waitress. Hairdresser, on the other hand, is pretty neutral. The machine learning model, looking through all that writing, has encountered similar numbers of male and female hairdressers. But look at coach. It is very male, even though obviously there are many female coaches in real life. It's that the machine learning model has encountered many more male coaches than female ones in scanning that written material, and so it learns that coach is a male occupation. The machine learning model has therefore become implicitly biased. Again, the reason that this happens is that in the real world, when we look at lots and lots of writing, coaches tend to be male. Here, we've depicted search term frequency for two top male coaches and one of the most famous female coaches of all time, Pat Summitt. As you can see, the search term frequency for the male coaches is an order of magnitude higher. Occupations tend to be associated with specific genders. So, by using occupation as an input to our machine learning model that decides whether or not to extend a loan, we may be providing a backdoor entry to the use of gender. This property of machine learning models leads to reinforcing existing biases in society. It's one of the things that we have to be on our guard against. It comes down to understanding our data, really understanding it, and understanding some of the implicit biases that ride along with that data.